Welcome back to my mathematical fanaticals. Today we are going to actually jump into a Chapter 6 lesson from Chapter 6, Lesson 5, because it goes along with what we're doing, except this time instead of equalities where we're graphing linear equations, now we're going to graph linear inequalities. So here are a few steps that you want to make sure you keep in mind when graphing linear inequalities. We want to make sure that our inequality is always in slope-intercept form. So that means we need to make sure that that y equals mx plus b is always how it's set up. Except we are going to trade that equal sign for an inequality sign. So then we have to decide, whoa, I've got an update apparently. Now we need to decide, is our line that we draw going to be a dashed line or a solid line? And here's how we know the difference. A dashed line means that it cannot include the points that would be on that line. That line just serves as a separator. So a dashed line is when we have greater than or less than. A solid line is when we have greater than or equal to or less than or equal to. So that equal to piece means that the points that sit on that line would actually work. Third step, we graph the line using our slope and our y-intercept. And finally, we have to do some shading of the region by substituting a test point. So we pick a point that falls in our shade where we believe the shading should go. We pick a point and we try it. And if that point makes that inequality true, then that's the side of the line we shade on. All right, so we're going to get going here. We're going to, whoops, sorry. Alrighty, getting a little crazy early in the morning here. I am going to just pick a different color here. All right, so first of all, I look at number 1 here and I see that it is in y equals mx plus b form. Instead of the equal sign, we have a less than sign. So the first thing I do, make sure it's in that form. It is. Now I look at what my sign is. Since it is less than, I know I'm going to have a dashed line. So now my job is to simply graph it using the slope and the y-intercept. So I see by looking the slope is 1, because there's 1x there, and it goes through a positive 2. So I'm going to place my dot there. All right, remember, this is a little off. We're just going to go with it. And because my slope is positive, that means it's going to go up 1, right 1, or it's going to go down 1, left 1. And so I can plot my points like so. Then I go ahead and I'm going to try this and see. I'm going to put a shape on here. We'll see if I can get it to work. Oh, except problem is it has to be dashed. So we'll ignore that line. I'm going to just make my pen a little thinner and we're going to put a dashed line. Remember the dashed line. Again, you should use your rulers, but just make it a dashed line. A dashed line indicates that we can't include any of the points on this line. They would not fit the less than piece. So now I have to pick a point. Well, I think if it's less than, that feels to me like it's something that falls below the line, less than. So I am going to go with the 0.00 just to see, because it's always a good one to try. So I'm going to make x and y both 0, and I am going to see if it works. When I substitute zeros in, this is what it looks like. And then I get 0 is less than 2. Now, since 0 is less than 2, that is a true statement, then that means 0 falls in the range of this problem, and so we simply shade under our line. All right, so it looks like this. So we've got a couple more to try. All right, I see, first of all, number 2 is definitely in the slope-intercept form, so we're good there. Then my next step is I look right here at my inequality symbol. Because it's got the equal to sign under, my next decision is it dashed or solid? It's going to be solid. Next item, I graph it based on its slope and y-intercept. Crosses the line at 4, so I go up 4, and it's got a slope of -1/3. So I know my line is going to move down to the right. So for every time I drop 1, I'm going to go right 3. If instead I went up 1, that's the positive move, then I have to go left 3. Whoop. We'll see if we can, it may not want 1 right up at the top of that. Okay, so we're not gonna go there because it's getting a little dangerous here. All right, now I know it can be a solid line. So we'll go ahead and try the move I was gonna do earlier. It can be a solid line, so I am going to draw my solid line through. All right, now I have to make the decision about how is this shading going to go? Again, I can use that 0, 0. So I'm going to try 0, 0 and see. Although when I look at this, my gut instinct says, ooh, it says it's greater than, so it's probably going to be above that, but we'll try 0, 0. If 0, 0 is false, then we know we have to shade above. So I put a 0 in for y. I take 0 times -1/3, and that's 0. And now I have to ask myself, is 0 greater than or equal to 4? It is not, so we know that this is false. Therefore, we need to shade above. So our shading would fall above the graph. What this is really saying is any ordered pair above this line would be a solution to that inequality. All right, when I look at this next problem, my dilemma is that it's not in slope-intercept form. So I need to rearrange it so it's in slope-intercept form. So I know this x is going to have to be kicked over here. So that will leave me -2y is greater than 4 minus x. Now, it's still not in slope-intercept form because that -2. So we need to make sure that we divide all of the parts by -2. So when we divide by that -2, remember what happens to my sign when I divide by a negative? It has to switch. So it becomes y is less than -2 plus 1/2 x. Whoops, running out of room there. All right, that should be a plus sign. So I'm going to rewrite it one more time. Y is less than 1/2 x minus 2. Now I know all of the parts I need to graph. First of all, or my next step is it going to be a solid or dashed? Well, because it's less than, it's going to be dashed. So I'm going to go down to my -2. I'm going to go up 1, right 2. Up 1, right 2. I'm also going to go down 1, left 2. And so I have now created what will be the border, and I'm going to make sure it is a dashed line. You will be using your rulers to help you do that. I still put my arrows on the end. Again, my gut instinct is it's going to go lower, but I can always use that 0, and that's kind of the nice one to use here. So I'm going to plug a 0 in. Half times 0 is 0, and I get 0 is less than -2. 0 is not less than -2, so I know the point 0, is not a solution to this equation. So I have to shade where that 0 is not. There's one other style of problem we can see, so take a minute and make sure that that makes sense, how we're deciding how to shade. There's one other way that we can do this. I now have to write a linear inequality for this graph. So, first thing that I see is it's got a negative slope. So I know it's got a negative slope. Let's try that again. It's got a negative slope. I don't know what symbol I'm going to use, but I know it's going to have an equal to in it. It goes through the y-axis at -6, and my equation is my up and down change is 6 when my across change is 3. So 6 over 3 would be a -2. -2x minus 6. All right, so now to me, my guess is it's going to be less than, because it appears to be shaded below the line. So let's see if that works. 0 is not in this solution, so I'm going to use 0 to plug in. 0 is less than or equal to 0 minus 6. Is 0 less than or equal to -6? That is a false statement, so that is why they've shaded below there. Therefore, we know this is the proper solution. All right, it's your turn. I would simply like you to try this one problem. Graph the linear inequality. Remember to follow the steps at the top of your notes page to help yourself out. Thanks. Happy graphing.